All right. So we're going to use what Sam was just talking to us about to help get us to a place where we can write equations of parabolas. So first thing I want to point out, how many points do you need to write an equation of a line? 2. Okay? 2 points to write an equation of the line for 2 reasons, really. Okay? Reason number 1 is that it has a consistent slope. It grows at the same rate. So once you establish how far apart 2 things are, you can continue to find all the other points on the line. Reason number 2, if you think about something like y equals mx plus b as one of the forms of the equation, there's 2 missing pieces to writing the equation, the m and the b. And in order to find those 2 missing equations, you'd have to have 2 different relationships in order to solve it. Okay? So a parabola is a little bit different. If I gave you 2 points, would you know what the parabola necessarily looked like? No. All you would be able to do is draw a line through them. You don't know if they're the vertex point, okay, points on the same part of the parabola. You have no idea, okay? So it takes more than that. It takes 3 points to graphically be able to draw any sort of parabola, okay? And to establish the relationship, because in a parabola equation, there are more missing pieces. It's not y equals mx plus b as like the standard form that we would be looking at. Instead, we would be looking at y equals my computer's like a little slow, ax squared plus bx plus c. Okay? So notice it's not m and b that I'm looking for in here. I need to find a, b, and c to finish this equation, right? That's 3 different things that I have to know how they are related. So instead of just needing 2 points, I would need 3, okay? The reason I didn't choose to start with vertex form here, I probably could, but it's because they didn't give me the vertex, so I feel like I'm going to go with standard form. If they gave me information about the vertex, I probably would have started with vertex form, okay? So I really don't have much information at all. I just have these 3 random points. So remember what we were just talking about with Sam, how we would figure out those last things, that every point someone gives you on a parabola is an xy pair that could be used in the equation. So when they say this parabola goes through the point -2, -4, made from a times -2 squared plus b times -2 plus c. Or in other words, if okay, -4 equals 4a minus 2b plus c. Okay? So that's an equation that relates a, b, and c together, 3 variables. But one equation is not enough for me to solve for the 3 variables because I have to understand their relationship multiple ways to be able to figure it out. Okay, one equation is only enough when there's only 1 variable. If we had 2 variables, we need 2 relationships. When we have 3 variables, as we've seen, because we solved systems of 3 unknowns, right, it required 3 different relationships to figure them out. So yet another reason why we need those 3 points to establish the equation. So I'm going to do the same idea with the other 2 points to develop other equations or other relationships between A, B, and C. Equation would say -1 squared plus b times 1 plus c, a plus b plus c. And then my last point is 311. So is equal to b times 3 plus c, or again, plus 3b plus c. So from those 3 points, and knowing just the standard form of a quadratic, I can develop a system of 3 equations or 3 relationships with these 3 things, A, B, and C. I should be able to then solve this system of 3 equations and 3 unknowns in order to find A, B, and C, because my goal is to be able to write an equation with coefficients in it, not just in like a generic form. Okay? So I guess I'm going to go ahead. I'm going to take the first 2 equations here on them. 2 equations. I'm going to multiply the second one by a negative, and then I'll combine them together. Okay, so I'm taking the first equation plus a negative times the second equation. If you're wondering what process I'm doing, that's going to help me get rid of C. I targeted C just because it doesn't have any coefficients in any of the equations, so I thought that that might be helpful. So I get negative 3 equals 3a minus 3b. And then I'm going to do the same thing, but this time I'm going to do the third equation with a negative times the second equation, also to get rid of C. So this should be review for you guys, right? This is just one way of going about a system of 3 equations and 3 unknowns. All right, so what do you guys want to do at this point? What do we do when we get to this point and we're trying to solve for these 3 variables? Yeah, Aubrey? Perfect. Okay, I'm just going to continue doing elimination with these two to eliminate another variable. So if it's okay with you guys, I'm going to get rid of the b's by multiplying this equation by 2 and the other by 3. So I'm going to multiply this equation by 2. And I'm going to multiply this other equation by 3 because that's helping create this positive and negative 6b. Then I get 30 equals 30a. So I get that a is equal to 1. Okay. What do I do once I've found a piece of what I'm looking for? Edwin? Good. I plug it back into one of the equations. So I'm going to take a value and plug it back into one of these. I'm going to do negative 3 equals 3a minus 3b. So I end up with negative 6 equals negative 3b, so b is equal to 2. And then finally, I do want to keep plugging in to find c. I'm going to take this second equation right here. Okay? And so I'm going to have negative 1 equals a plus b plus c. Okay? And then I'll find that out. Yeah, Aubrey. I multiplied 12 times 3. That's from this equation right here. Is that okay? So I have an a of 1, a b of 2, a c of negative 4. But my question was to write an equation of a parabola that crossed through all these points. So you don't just stop with a, b, and c. You go back to your equation and you write it as an equation. An equation that goes through all these points is 1x squared plus 2x minus 4. That's the equation with the correct coefficients that goes through all of those points. Okay. Is this idea okay with everybody? So Sam's idea, the question he asked about, was really important. It wasn't just a homework problem to establish this or that. You're going to see lots of questions asked in that way. And the big idea behind it is there's either some extra equations you know about how the parabolas work, and then on top of that, there's these points that you have to understand can be plugged in as x and y simultaneously to get rid of some of those variables and help you focus on finding the missing pieces that you're looking for. Okay? Any questions about this? No? Hope for one that has 0 as the x, right? Because then when you plug that in, you'll have c and you won't have to deal with a and b. Okay? So that would be like a nice version of this. Okay? Any other questions on this before we change screens and look at the other part of it? No? Okay, so the second part here talks about data. And so we're going to go ahead and try to remember how to put data in our calculator. Okay? So we are building equations in different ways. One way is just by knowing the relationships of how the parabola works with some points. The other way is having data and letting the calculator find the best. When we look at this problem, there's a data table, okay? Data's a little bit different. We need to look at it first to even understand what shape is. And then secondly, even if we can see kind of a shape, data might not fit one perfect parabola because data is real life values. The parabola doesn't necessarily have to go through the data points, just like our best fit lines didn't necessarily cross through all the data points. So you have to treat data a little bit differently, okay? So this question asks, what's the quadratic model for this data? Remember, when we're asking for a model, what are we asking for? An equation, okay? Which equation represents the data? So we're going to go to our calculator, and we're going to enter this data in. So this is something that we should be familiar with. This is not any different than before. So when you get your calculator, you're going to go to Stat. So we're going to go to Stat, Edit. I don't need anything that's in the list right now, so I'm going to clear them out. I am not doing this at a pace that is to teach you how to enter data because I think you already knew how to enter data. And then our note guide actually gives us a hint. Let me see. Just go up to the top and press clear. Okay, so before we enter in the data, we can't enter the times as times, okay? Because there's two 2 o'clocks in our day, and there's two 12 o'clocks, and like the calculator is not going to understand that, okay? So we're going to go ahead and enter it like a military time or like a 24-hour clock. So like midnight, 12 a.m. is like 0, okay? And then 1 a.m. is 1, 2, 3, 4, and then noon is 12, but then 1 p.m. is 13, and 2 p.m. is 14, etc. So when we look at our data, the first is 8 a.m. with 52 degrees. So the first thing I'm going to put in list 1, is 8, because 8 a.m. is still 8. Then it has 11, that's still 11. Then it has a 2 p.m. A 2 p.m. is really going to be 14 for us. 5 p.m. is going to be 17. 8 p.m. is going to be 20. And 11 p.m. is going to be 23. And then I'm going to just put the matching temperatures that goes with each of these. So at 8, it was 52. 11 was 59. 2 was 63. 5 was 63. 8 was 58. And 11 p.m. was 56. Okay. So I should have 2 data tables that are the same length, and I just adjusted the time so that I didn't have these weird overlapping numbers because the graph is not going to understand that. Then remember, if we want to do a scatter plot, okay? So first thing I'm going to do is I'm going to click the y equals button and clear out anything else I have in there right now. So I'm going to go to y equals. I don't want to see the graph of this other thing. I'm going to press clear. Okay. Now I want to turn on the scatter plot. Remember how to do that. It's all up here at stat plot. So I'm going to go second and then y equals. I need to go inside one of these and turn it on. And I need to make sure it's set for the scatter plot and the appropriate lists. Okay? Now, before I go and look at the graph, who remembers how we should zoom? Kylie? Good. Zoom 9. Okay? That will do your data automatically for you and scale your graph according to the data. So I'm going to press zoom, and I'm going to choose choice 9. There's my data. Okay? Now, we're going to get a quadratic model for this data rather than a linear model for this data. Can you look at the data and see why we'd prefer a quadratic model in this case instead of a linear model? If I only look at half the data, it looks like a line might work fine for either half of the data. But when I look at all the data together, it clearly had one trend going one way and then another trend going the other. I need something that fits kind of that trend where it curves. So that's why we're choosing a quadratic. Okay? Remember when the calculator gives you an equation, we go back to stat. Okay? We go over to calc. And we are running a regression, but this time not a linear regression. We are running a quadratic regression, so number 5. Okay? We don't have to store it. We'll just write it down. So go ahead and press enter or calculate if you have that menu. And I'm going to make a little note about what it says before I write it down. So going back to the question that we were asked, the first question is, what is the quadratic model for this data? Okay, and we were supposed to round to the nearest hundredth, so I did that with my values. So the quadratic model for the data is the equation I would get. And they gave me an A, B, and C, like the equations in standard form. So the best equation that I can get for this data is to say y equals, say, negative 0.16x squared plus 5.14x plus 21.60. All right. What does x represent in my equation? We put in the data. What were we using as x? Good. Time. Okay. And what does my y value represent? Temperature. Good. Okay. So then it says, use your model to predict the high temperature for the day. At what time does this predicted temperature occur? So this is a parabola that faces downward. Okay. Where would the high temperature occur on the parabola, Thomas? At the vertex. Okay. How do I find the vertex of a parabola in standard form? Now, if we graphed it, we already went through how to do it on our calculator, right? How to find maximums or minimums. So let's say we just had the equation. What could we do numerically to find where the vertex is? Edwin? Okay, good. So I'm going to do x equals negative b over 2a. And I'm going to figure out what that is. I guess stole all my calculators. Thanks. Where did it go? So we get 16.06. Is that okay with everybody? Somebody double check that I'm right. So the x coordinate of the vertex is 16.06. What's the y? How am I going to find the y coordinate of the vertex? Sam? I'm going to plug it into that equation. So negative 0.16 times that's 16.06 squared plus 5.14 times the 16.06 plus 21.6. And then somebody else check me, but I got 62.88. Thank you. So the first question was, use your model to predict the high temperature for the day. Okay, so what did my model predict is the high temperature for the day? 62.88 degrees, right? So the high temperature, according to my model. Now, you might have saw something on the data that was higher than that. So the inside of you might want to be like, no, that is not right. But it's according to our model. Nothing fits this data perfect. We're trying to make predictions based on trends we see, so we have to use the equation, not the exact data. Okay? Then it wants to know at what time does the predicted temperature occur. Okay? So what represents the time in our vertex? Riley? The x. Okay, so 16.06, which is real close to 16. What is 16? 4 p.m., right? Afternoon? Okay, so about 4 p.m. Is this all right with everybody? So see how the data is going to be important? We're going to use it in lots of different ways with different types of regressions. So knowing how to do that stuff on the calculator is important to us. Okay? So